First problem is the wheel rotates from point A to point B and it has a mass of 8 kg. The radius is 0.3 meters and then radius of gyration about its center is 0.25 and it is released from rest. So what it means is that kinetic energy at 1 is 0. And determine the velocity of the center. So Vg at the bottom of the hill. So here, what is that Vg? That's the question. So let me show it correctly because at top it is at rest. So Vg here. What's that equal to? So it rolls without slipping. So we will apply the conservation of energy, kinetic energy at 1 plus the potential energy at 1 will be kinetic energy at 2 and then potential energy at 2. And then this will be the coordinate y. At 1 the kinetic energy is 0. The potential energy at 1 is that m, g and y. Y is 4 meters, m is 8 kg, so that means that is mgy at 1. And at 2 mgy and then y is 0, therefore it is 0. Okay, so it means that change in potential energy is converted into kinetic energy. So let's find the kinetic energy of the wheel. So kinetic energy at 2 will have two components. One will be due to rotation and then other one will be due to translation. The Ig value, we can find it from the radius of gyration, which is 0.25. So that will be the mass is 8. That will be so 8 times 0.25 times 0.25. So that is 0.5 kg into meter squared. M is 8 kg and then omega is unknown, and then we can replace the Vg value. This is the Vg and this is R value. Okay, and then this Vg is omega into R. Okay, that is by using the kinematics. The R value is given as 0.3, so that will be 0.3 omega. The M is 8. So if you do that, kinetic energy at 2 will be 0.5. So we have 1/2, again 1/2 omega squared plus 8 times 1/2, 4. 4 times 0.3 squared, 0.36 omega squared. 0.25 is this one, 0.36 is that one, 0.61 omega squared. Okay, that is the omega value. And then we have the potential energy, which is 8 times 9.81 times 4. That's 314. So 314 will be 0.161 omega squared, and then from here omega squared will be 314 divided by 0.61 and then 515, and the square root of it 23. So 515, and then omega is 23 radians per second. Okay, the question says find the velocity. This is at point 2. Yes, I should add the omega 2 here, all of it, because it's at point 2. Then velocity at 2 will be, again, I will use this formula here, omega 2 into r. And then omega is 23, r value is 0.3, and then that will be 23 times 0.3, 6.9 meters per second. This is a very simple example that shows the application of the conservation of energy for a wheel that rotates downhill.